Hello, friends. Welcome back to the Awesome Algebro. Today, we're going over arithmetic sequences. So, arithmetic sequences is a very easy concept that goes in a 1, 2, 3 easy format in order to help you get any number in the sequence. Now, we do that by doing what's known as the nth term, which is basically the formula of the sequence. Can you get the formula or the equation of the sentence? Now, an arithmetic sequence is a pattern where you try to determine what the next term is by adding or subtracting to get the next number. So you're going to either add positive or you're going to subtract negative in order to get the next number. To start off, we're going to look at an easy pattern: 4, 7, 10, and 13. Now, 4 is our first term, 7 is our second, 10 is our third term, 13 is our fourth term, and whenever you see the dots, that just means that the pattern is going to continue. So let's take a look and see how can we get the nth term, meaning the formula, in 3 easy steps. Step 1, you want to determine how much the sequence is increasing or decreasing. If it's increasing, that will be a positive number. If your sequence is decreasing, that will be a negative number. So let's see. To go from 4 to 7, let's look at the pattern. To go from 4 to 7, what's happening? Plus 3. To go from 7 to 10, what are we doing? Plus 3. To go from 10 to 13, what's happening? Plus 3. So what is the sequence doing every time? It is increasing by 3. So that would be positive 3. If it's increasing, positive number. If it was decreasing, a negative number. Okay, step 2. Multiply that number by n. Now you might ask, what number? Multiply this number by the letter n. So if it's a positive number, that would be 3 times n. If it was a negative number, multiply that number by n. In our case, that would give us simply 3n. Now, third step, add the zero term. Now, the zero term is what number, if you followed the pattern, could you put before the first term? So we follow the pattern. Now let's look at the sequence. We had 4, 7, 10, 13. What I'm asking is, what number could you put in front of 4 that would still fit the sequence? Now again, every number is being added by 3 to get the next number. So what number, theoretically, could you put in front of 4 that would still fit the sequence? That would be known as the zero term. Now again, think about it. There's a number plus 3 that would have given you 4. That number would be simply 1. Now, 1 is a positive number. So we would put our 3 in, and then we're going to add the zero term, which in our case would be positive 1. So 3n plus 1 is the formula, is the nth term for the sequence. We can use this formula to get any number in the sequence. So let's put that to the test. So we're going to use that formula to get even bigger numbers than just the first, second, third, and fourth that we had earlier. So our formula, once again, is 3n plus 1. I want to know, what is the 28th term? Now, Rn stands for number. N is for number. What number are we looking for? In this particular case, we're looking for the 28th number. So we're going to replace the letter N with the number 28, whatever number that we happen to be looking for. In this case, we're looking for 28. So we will replace N with 28. If we are looking for the 100th term, we will replace N with 100. Whatever number, remember, N is for number. Whatever number you're looking for, just replace your number with the letter N. So in our case, since we're looking for the 28th number, we'll replace the n with 28. So it would be 3 times 28 plus 1, which would give us an answer of 85. So the 28th number in the sequence would be 85. And you can use that formula to get any number in that sequence as well. Now let's take a look at a few more examples and a few more patterns and see if we can get the nth term even faster. Now let's look at a few other sequences and see if we can figure out the nth term pattern as well. We'll start with 50, 43, 36, so on and so forth. And again, you can solve any term in the sequence with the 1, 2, 3 steps of the nth term pattern. We're trying to determine, can we get the formula that will help us get any number in the sequence? So what is the nth term? Or what is the formula that will get any term in the sequence? It's just an easy 1, 2, 3. So first step, identify how much the sequence is increasing or decreasing. If the sequence is getting bigger, that would be a positive number. If it's getting smaller, that would be a negative number. So in this case, to go from 50 to 43, what's happening? That would be minus 7. To go from 43 to 36, what's happening? Minus 7. So the pattern so far would simply be minus 7. That's happening every time. Second step, multiply that number by n. So that would be negative 7 times n, which simply gives you negative 7n. And the third step is add the zero term. The zero term is what number would go in front of the first term if you followed the same pattern. In this case, it would be 50 to 43 to 36. But based on that pattern of going down by 7, what number could you put in front of 50 that would make the pattern still continue the same way? So in our case, we have to think we already started with 7n. Now we're trying to see, okay, based on the pattern, what number could you put in front of 50? Now again, the number that will go in front of 50 has to be subtracted by 7 in order to get that 50. So what number, based on the pattern, could you put in front of 50? That would be 57. 57 is a positive number, so you would put down negative 7n plus 57. That is our formula. That is our nth term. And that will give us any number in the sequence. So if I asked you a question like, what is the 20th term? Instead of you subtracting 7, subtracting 7, subtracting 7 20 different times, you can simply plug the number into the formula and get the answer within seconds. So our formula is negative 7n plus 57. N is for number. The number that we're looking for is 20. We're looking for the 20th term. So replace the n with the number 20, and you'll get whatever number you have, or you get the answer for that sequence number. So in our case, if we replace n with 20, that would be negative 7 times 20 plus 57. And once we solve for that, we get negative 83, meaning the 20th number in the sequence is negative 83. Now, let's go a little bit faster when we do the next one just to see if we understand the steps. Okay, what is the nth term or what is the formula? Step 1, identify how much the sequence is increasing or decreasing. Well, to go from negative 7 to negative 1, that's getting bigger. That would getting bigger by 6 plus 6. From negative 1 to 5 plus 6. From 5 to 11 plus 6. So positive 6 is what's increasing by every time. Second step, multiply that number 6 by n. That would give us 6n. Third step, add the zero term, meaning what number could you put in front of negative 7 that would fit the same pattern? Now, you're going to be working with negative, so you have to definitely put on your thinking cap. But you have to ask yourself, what number, based on the pattern, would go in front of negative 7? We already have 6n, so we just need to see what goes in front of negative 7 that follows the pattern of plus 6. What number plus 6 would have given us negative 7? In this case, they would have been negative 13. Negative 13 plus 6 does give us negative 7. Well, negative 13 obviously is a negative, so we will put 6n minus 13, or 6n negative 13, depending on how you want to say it. So this is our nth term. 6n minus 13 is the nth term. It's the pattern of that sequence. Now, we can use that pattern to get any number in the sequence. So if I ask you what's the 53rd term, you would start with your nth term and replace your number, n is for number, with 53. So it would be 6 times 53, your number, 53 is your number, 6 times 53 minus 13. And our answer would be 305, meaning the 53rd number in the sequence is 305. Hey friends, Thanks for watching the Awesome Algebro. Please be sure to like, comment, share, and subscribe for the most awesome algebra tips available. And again, thank you for making me a part of your day.